What's going on, everybody? My name is Caleb, and this video is going to be everything you need to know to get started with structs in C. We're also going to talk about some of the differences between structs in C and C++, because they are not the same thing. So throughout this, we're going to talk about how to create a struct, how to use it, proper syntax, some variations, and things that you need to look out for. So let's get started. First thing though, I wanted to mention I am releasing a C and C++ master course, which is going to give you everything you need to know to thrive and excel in the C++ environment. So if you want to get notified when that is released, I'll drop a link down to my newsletter. That'll give updates for any upcoming content and course releases and everything else. So check that out and let's get started. So we're going to build up kind of slow. So if you're already a pro, this might be some review. What we're going to do is first show how you might do things without a struct. If you wanted to keep track of a series of points, and I'm going to leave this in a comment just to put some data here that we can refer back to. Let's say these points are 0, 1, and these just refer to some location. You can think of it on a grid or on a map in a video game, whatever makes this make the most sense. Where one of these coordinates is the x coordinate and the other one is the y coordinate. So we're just going to stick with 5 of them. If you wanted to store something like this, you might jump to thinking, hey, an array of x's and an array of y's. And let's just say we need 5 of each of these, so we'll throw a 5 in here and a 5 in here. And there's really nothing wrong with doing this. I'm not trying to say it's wrong. I'm just saying, for a simple example, you might not really notice the difference, but as you add complexity, it's going to get unorganized. Now we basically have to refer to each one of these separately, which means they can get out of sync, or you can just screw things up really easily. Basically what we're doing is we're going to go x0 and y0, putting these values, 0 and 1. We'll do the same thing for x of 1, which is going to be 2, and then y of 1, which is also going to be 2. And just typing this out, there's a good chance I'm going to screw something up, so I'm going to be really careful here. X of 2 is going to be 2, and y of 2 is going to be 3. And then what we'll have is x of 3 is going to be a 3, x of, gotta be careful there, which is going to be 4, and then finally x of 4, which is going to be 4, and y of 4, which is going to be 5. So hopefully you can see how I made those values. Just going to double check. We got 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and then the numbers line up. So 0, 1, 2, 2, 2, 3, 3, 4, and then 4, 5. Everything looks good. If we wanted to go through these values, you could imagine a path going from point to point. You might think to do a for loop. So what we'll do is we'll say int I is equal to 0, I is less than 5, I++. And inside of here what we'll do is just a quick printf. And inside of here, we're going to put the x and the y, so we'll need 2 integers displayed, and then we'll go to the new line. And if you want, you could put these in parentheses like so, and you can even put a comma to make it look pretty similar to what we had up there. Then we'll grab x of I and y of I. Let's run this, see if we get what we were expecting. And you can see it matches that format that we originally defined up here. So far so good. You could, of course, use this system. The value that structs introduces is that you'll no longer have to have this data split across 2 different arrays. You can have each one of these points combined together into a single data structure. So to create a struct, you can do this inside a main or outside a main. That's up to you. I'm going to actually do it outside of main, which will make it more accessible throughout our code. And we'll say struct point. And inside of here, we're going to define an int x and an int y. And after the struct, you'll have a semicolon. So this is what your code's going to look like. Now naming conventions, kind of up to you. I'm going with an uppercase P. That's because I want to clearly see that this is a type and not a variable. That's a convention I've kind of picked up, and some other people follow that as well. This is lowercase, as it's a data member of this struct. So what this struct does is it stores information, and right now it's just defining that structure. We haven't actually created an instance of this. Now you might be thinking this is pretty similar to object-oriented programming, and it is quite similar, but there's a lot of features that are lacking in C, So you can't really say it's an object-oriented programming language. Really, this is just a way to organize data. In C++, this would be an example of a pod, a plain old data type. Now, what we could do is, instead of having these separate, we could just create individual points. And to create a point, it'll look like this. Struct point, and then give it a name, such as point with a lowercase p, so now I can distinguish between the type and the variable, and then we could put those values in there, such as 0 and 1. You can access the individual values. I'm going to zoom in here just a bit. We don't need to see everything. Let's just go ahead and do %i, and you'll say point dot and select x, and then point dot and select y. So that is how you create an individual point and access the members on that point. So when we run this, we should see that value. It's right here. So it's formatted a little wonky because I didn't put a new line, but you can see 0 and 1. So what we could do is we could do this similar structure for all of these, and then we wouldn't have to worry about having our data split up like that. It's also worth noting that you can access these data members and assign them values not like this, but actually one at a time. So you could say point.x is 0 and point.y is 1. So you know how to create an individual point, but how do we go about creating multiple points? Well, I still want to create an array. So what I'm going to do is I'm actually just going to clear this all out, and we can use our struct type anytime we're expecting a type. So we can say struct point path, give it a size, and you could put a value in here, or you could just let it decide that from the initialization, which I think is a better option. And then we can define our paths inside of these curly braces. So let's go ahead and define them one at a time. 0, 1. 2, 2, 2, 3, 3, 4, and 4, 5. This is how you create an array of paths, which, as you can tell, is a lot easier than doing all this. So let's go ahead and clear that out. And now we have an array of paths. However, our code down here is going to break. So how can we go about doing the same thing we were doing down here? Well, instead of accessing x of I and y of I, we can just access the individual path item, so path of I, and then use the dot operator to access an individual element, such as x. And then again, path of I dot y. So this should work the same way and give us the same output, but it's way cleaner than the other code. So that is the basics of working with structs. Up now, we're going to talk about using other data members, such as a string, which is an array of characters. So now we won't just have 2 integers, but we'll have 2 integers and a string. So to store a string inside of a struct, and I'm actually not going to change this one right now, I'm going to create a new struct. So we'll say struct, and this time, let's go ahead and represent something such as a city. So now we're getting a little bit farther away from the abstract concepts to real things. So a city, what's a city going to have? Well, it might have a name, which will be represented as a char array up to 100 characters, which really gives you 99 characters and 1 for the null terminator. And it might have a population. So here's an example of what a city struct might look like, and don't forget that semicolon. So if we wanted to create a city, we can come down here in our code, and I'm going to comment out this section for a minute with holding command and hitting the / key. We're going to say struct city, city1, and we're just going to initialize it with some data. I generated some cool names online, so let's go with Violetville. This has a population of 2,300 people, and you could do the similar thing for more cities, or of course you could make an array if you wanted. So Violetville, we'll go with Sapphire Springs. That one's pretty cool sounding. Let's say this one has 4,000. And let's go ahead and make a third city. This is Glenhaven, and it has the value 12,000. Let's talk about how we can print some of this data. So we could do a printf. I'm just going to do a single city right now, and we'll talk about putting this in an array in a little bit. Basically, we might want a string and a number. So what we could do is we could say city %s to represent a string, has population %i to represent an integer, and then a new line, and we could put a period there too as well. So the first value to substitute in is going to be city1 dot name, and then the next thing will be city1 dot population. So that's how you're going to print a single city. And you see city of Violetville has population 2,300. If we wanted to make this an array, you can go ahead and try that now. I'm going to go ahead and finish that. So what we'll do is we will define an array, struct of type city, calling it cities. We'll give it a size 3, or you can just let it figure that out from the initialization. And then we can just remove the left-hand sides here, closing up the curly brace and replacing the semicolons with commas. So that's how we can create a cities array. Now I want to talk about how we can iterate through these and print all of them. So let's say for int I is equal to 0, I less than 3, I plus plus, print f, and we're going to need a %s and a %i. And then for the printing, we can say cities of I dot, and you can grab the name or population. So we'll go ahead and grab the name, and then cities of I dot, and this is going to be population. For some reason, this gives me a compilation error saying too many arguments in function call. However, I'm pretty confident this works. We might just want to improve that formatting. So something's going on with the syntax highlighting, but overall this works, and that is how you would iterate through the data and print it. I was able to fix this by disabling error squigglies and then re-enabling error squigglies, and that error went away, so hopefully that stays away. And there we go, we got the output we were expecting. The next thing I want to show is how we can create a struct that has another struct inside of it. This makes sense because when we create a struct, we're really creating a new data type, and we can use that data type anywhere a data type is expected. Just like you put integers in your struct, you can put your custom data type in that struct as well. So right now we have these two structs, point and city. And a city has a name and a population, but it could also have a location, which you could represent with a point, an x and a y, like a latitude and longitude. So what you could do is you could say, hey, this is going to be a struct point, and then give it a name such as location. Now, when you initialize these, you can add those values in. And right now, I'm showing you hard coding all these values, but you could get these from input or apply them later, however you want to do it. This is just the easiest to represent the concepts I am showing. So let's go ahead and give these some positions. And I'm surrounding those in curly braces. However, I don't believe that is required, so this compiles, but you could also remove these. It's just going to be a little less clear, in my opinion. So we should be able to compile that as well. So I'm going to add those back in, but just want to let you know that that is possible. And now to access this data, we have to traverse one layer deeper. So let's go ahead and not only display the population, but the location as well, which will be an x and a y. So %i for integers. And then I'll just jump to the end here. So for example, cities index I dot, and you should see now a location. Well, location itself is going to have an x and a y, so you can just display them like so. Cities of I location dot x and cities of I location dot y. Saving that, it brought it down to the next line for me. We run it, and you can see those locations. There you go. That's how you can work with nested types. I want to show you a little tip, which is how you can calculate the size of an array of this new type. You could do this with normal data types like integers, but you might not have thought to do it with structs. So you can say int size, and then get size of operator of cities, dividing it by size of cities index 0, and then a semicolon. This should then be replaced here, size, and just to make sure I'm not crazy, I'm just going to print that real quick. So %i size. Running this, we get the value 3, and the loop still works as expected. So that's how you can calculate the size. And you can pass these to functions just the same way. So for example, outside of main, let's go ahead and create a function, void print cities, and we'll just make this take a struct city array. So this is the name of it, and then the type of it is struct city. And we'll also take an int size here as well. And then inside of here, we're just going to take this for loop and move it up there. We're going to calculate the size on the outside, so We'll paste that in here. And I'm actually going to rename that to cities just for consistency's sake. It's not a singular city, it's multiple cities, so that makes a little bit more sense. And then we'll just invoke that, so print cities, passing in the array cities and the size, which is called size. Running this, we'll see that we get the same exact output. Next thing I want to talk about is the concept of a typedef, which is how we can basically define a global name for a type. And this is important, but also potentially dangerous, so some people don't recommend it, but I'm going to show you how to do it, show you the benefits, talk about some of the downsides. Basically, you've probably noticed every time you want to use this type, you have to prefix it with struct. Who has time for that? That's like an additional 6 characters. 7 if you include the space. So you know what? I'm going to get rid of that. They cannot tell me to do that. But then our code doesn't work. So what we could do is basically say, hey, we want this to be a type that we can use directly rather than prefixing it with the struct keyword. And to do that, we say typedef before struct and then give it a name down here such as city. Now this name here is technically optional. You can just use an anonymous struct, but there's some minor differences you can research if you wish. Some people recommend leaving this on, some people take it off. Not a huge deal in our case. The only time it really matters is if you're creating a struct that has a type of the same type that you're creating. So, for example, in a linked list, you might have a node that points to another node. But in our scenario, I think it's perfectly fine to have like this, so we're going to do that. We'll say typedef, struct, and then we'll move the point down to after the curly brace. And then again, this is calling us out here because we have an incomplete type. And basically when you don't have that name here, so if I put that back for a second, this is going to work because you could use struct point or point. When you remove this, you have to use that new typedef. So it's only going to work with point location and not struct point location. This is going to clean up your code, in my opinion, a lot and look a little bit more consistent with what you might expect in C++ or other object-oriented programming languages, where you don't prefix a type with what it is, like a class or a struct or whatever. You can do a very similar thing for enumerations inside of C, but we're just going to talk about structs in this video. If you want to know more details on enumerations and types, then check out the course. I'll leave a link down below again, which will give you a notification when the course is out for release. The downside to creating a typedef is that the name here is now going to be global, so it could cause naming conflicts if you have other things that are called point. It just basically increases the risk of that because when you have to prefix everything with struct, your only chance of naming conflicts are with other structs. But if you just make a name that has no qualification, it can conflict with anything. So a lot of people don't recommend it, but for this simple program, it's not that big of a deal. So those are the essentials of structs. We're going to cover a little bit more, but I just wanted to mention at this point, you should have a pretty good understanding. I wanted to talk a little bit about the difference between C and C++ because structs exist in C++, but they're completely different. Inside of C++, you can basically think of a class and a struct as pretty much the same thing, whereas C only has structs, and they're very basic just to store data members. C++, on the other hand, structs and classes, you can have different methods, which are basically functions, and you can do things like inheritance, encapsulation, polymorphism. You can't do that inside of C. We can emulate some of these behaviors. For example, we could create a function that will create a struct instance for us, and in object-oriented programming, that concept would be called a constructor, but inside of C, we would probably call this a generator. It generates a new struct, and it's not actually defined inside of that struct. So if I'm losing you, well, that's why I said we already kind of covered the essentials. This is more like the advanced extra information section. But we're going to go through an example of that real quick, where we have a function that will create a struct variable for us. It's not going to create the struct definition. It's going to create essentially an instance of this struct, a variable of that type. So what we'll do is we will create a function that will actually return a city, and we'll just call it create city. And what we'll do inside of here is we're going to create a new city. We'll just call it city with a lowercase c. And we're going to take some data to create this city for us. So we'll have a name, that's going to be a char array. So let's say size, what did we define it earlier? It looks like we defined it for 100 characters, so we'll do the same thing here, which I don't even think that's actually a requirement, but you can use that for kind of like self-documenting code saying that's what the name size should be. Int population. So we're basically going to pass in the name and the population, and it'll create a city for us. But we can do other things like data validation and basically emulate some of the object-oriented programming principles. So for example, we could say city.population, assign this the population that was passed in. To do some data validation, we could check to see if the name is null. So if name is equal to null, we'll give it a default name. So strcopy, and we're going to go into city.name and then pass it some value so you can make up a city name. So we'll just go with Lumbridge here. And if it's not null, then we'll just keep what was passed in. So city.name is going to be assigned the name that was passed in. So you can see this wouldn't really be possible inside of the struct definition because you can't put functions inside of it. So we're basically just creating a function outside to help us and give us that valid city back. And then later we can return city. I think for this create city to work, we're going to have to include something to copy strings. So that's going to be include string.h. Now we should be able to add one to this array. So you could try this where you say this is size 4 and then say cities index 3 is a new, or actually create city, passing in, let's just say null for the city and then 1,000 for the population. Run this and you can see we have some data here, but it's not exactly what we were expecting because you can see the location is just some random number. Not too good. So we can pass that in, or what I'm going to do is actually just generate a new location on the fly. And you can do that with random numbers. So I'll show you the code to do that. We're going to say srand, passing in time null. And this is how you can seed a random number. And basically this is a requirement to use rand. And then rand's going to return some large number, and you can get the remainder of division with 10, and that'll give you a number 10 or less. So we could basically use this to just generate x and y coordinates. So for example, city.location.x is rand, and we'll do the same thing for y. And to do this, we're going to need to include a few things. So we'll need to include time.h and include standard lib.h. Now let's run our main code, and you can see we get 1 and 1. Let's see if that was a coincidence. 2 and 1, 3 and 8. There we go. So you can see we're getting some random numbers anywhere between 0 and 10. And actually a quick note, this will never return 10. It'll only return 9 or lower, not 10 or lower. And that's because if the remainder of division by 10 was 10, well then it wouldn't be a remainder. It would just increase the actual result, and the remainder would be 0. So a remainder of 10 is essentially 0. That's my introduction working with structs in C. I'm sure there's so much more we could talk about. Thank you so much for watching. Let me know if I forgot anything or anything else you'd like to see a video on down in the comment section below. And again, definitely join my newsletter to be notified of my upcoming C and C++ course, as well as other free content on my YouTube channel or other channels like Free Code Camp. Wherever I might create content, that's where I'm going to notify you. So definitely join that, and thank you so much for supporting this channel. I'll see you in the next video. I think the next one we're probably going to talk about the string class in C++, but I'll probably look into creating some more C content as well, so that's going to be my focus here for a little bit while I work on these courses. So stay tuned. I'll see you in the next one.